I'm going to talk about something that really gets to the idea of the lesson. You can copy this or not. Maybe not. Maybe just listen to what I'm going to say, and I'm hoping that when I'm done, I'll write a sentence that you'll go, huh, that makes a lot of sense. Let's imagine I come up with a game for us to play. And we go out into the open parking lot, not the one with all the cars. We go find an open spot in the parking lot, and I get a calf cookie. One calf cookie, which I put on a plate in the middle of the parking lot. And I say, we're going to race. All of us are going to have a race. Whoever gets the calf cookie first gets the calf cookie. So right there in the middle, let's see how good my calf cookie drawing is going to be here today. Here it is, little calf cookie. Yes? Little calf cookie sitting there in the middle. And I tell, okay, if we're going to play this game, every one of you has to stand the same distance away from the cookie before we start. And then we're all going to run in. Maybe 2 or 3 concussions are going to happen as we make contact, okay? So, the first person in the class goes and stands here and goes there, that distance. Everybody else has to stand the same distance from the cookie. Circle, somebody already said. Yes? It's going to be a circle. At first glance, some people would say, oh, we all have to line up here. But that's not going to be fair to line up in a straight line, is it? That would be if there's a whole line of cookies. But there's not a whole line of cookies. Do we agree this is not fair? That's completely not fair. This person here in the middle has the huge advantage if I do that. To do it, the proper game would mean, and now we find out, okay, I'm going to actually get some help because my drawing skills sometimes are a little off. So I want a orange circle with white center, no, with blank center. I'm going to draw a circle here. Oh, that's not a circle. Circle. There we go. Orange, white. Let's see how I do here. Oh, better than I thought. That went a lot better than I thought. Let's just move this up a little bit, right about there. A little bit more to the other way there. There we go. Yes? Something like this. Circle's got to be bigger, doesn't it? The circle's not quite big enough yet. Bigger, bigger, bigger. Up a little bit. Now you're just playing around, Miss Todd.
If there's any other grade 9 students that would like to go to confession, please go to the Divine Mercy Room now.
Do you agree this is the fair game? Yeah? And a much better game from a concussion standpoint. Yeah? As we all come running into the center to get this calf cookie. So I'm going to write one sentence that will help you with today's lesson. The points that are, can I use the fancy word here? Equidistant. It's not that fancy a word. It's like obvious what it means. Equidistant from a fixed point. That's the calf cookie. Form a circle. It could be, as I finish that sentence, you are underwhelmed. You're like, yeah, obviously. Yeah, well, it's not that obvious. It's a pretty good little fact to know. Okay so far? Okay, now the lesson. With this in mind, with our calf cookie reference, ready to rock and roll. And making me a bit hungry. He's like, cut the nonsense examples. Am I getting a cookie? Well, you can call me on this later. Do we do measurement in here? Oh, maybe we don't. All right, I got an idea. You remind me, if we get past Easter and you haven't got a calf cookie from me, you remind me and we'll do the calf cookie activity. I've got an activity to do with calf cookies. Much safer than what I said. Okay? He wants an unsafe activity. Okay. Here we go. Equation of a circle. Develop the equation for a circle with center 0, 0. Can we do different centers? Yes, we absolutely can, but we won't yet. Okay, so don't worry about that. We'll set the center at 0, 0 for all our questions, and we'll work from there, and then we'll move on. So if we're doing the calf cookie, and we went out on the parking lot, I draw a big grid on the parking lot, and I'd put the calf at 0, or the cookie at 0, 0, okay? For now. It doesn't have to be that way. And apply the equation of circle in different contexts, whatever that means. That's the part of the sentence that should scare you. This is the last of the basic skills I'm going to show you, and then this chapter gets out of hand after that. I give you 2 or 3 basic skills, and then we go to work. And it's implying that right here. A blank is a set of all points in a plane that are the same distance from a given point called the center. A circle. That's the definition of a circle. Slightly phrased different than what you saw before. When we define circles in grade 3, we don't say stuff like this. We say it's round. It's perfectly round. Yeah? Now we're saying a circle is a set of all points in a plane that are the same distance from the center. Now look here. That word maybe sets off a bell in your brain. As soon as I say same distance, you're like, distance? Like yesterday's distance? Yeah, exactly like yesterday's distance. Coming up. The distance from the center to any point is called the, back to my calf cookie, that distance there, what's the fancy name for that? Radius. Okay, not that fancy a word. Hopefully you've seen that word before. And hopefully you know all about that word. The radius is from the middle to the outside. You might have thought of it as half the diameter, but it's going to be better for us to think of it as from the middle to the outside. The distance from one side of the circle to the other, right through the center, is called diameter. Yeah, so we got that word that's right through. That one's called diameter. And I only put those there just in case I use those in the lesson. I want you to be ready for those words. Do you have any questions so far? Haven't done much so far. Calf cookie, circle, radius, diameter. That's all I've done so far. Investigation. Use the length of the line segment formula. Calculate the length of OP in the diagram below. So, length of OP. Can anyone recite the distance formula without peeking at previous stuff? Is it clicked in your brain? So this is the idea of the homework. The homework was so easy. I know the homework was easy. That's no problem. The important part of the homework was now, when I ask for this formula, it's built into your brain because you've used it so many times. You don't have to go and memorize it because you already know what it is. Do you know what it is? What is it? x2 minus x1 squared plus the whole thing is square rooted. Now, I'm going to throw her off here. You can answer if you want. If you're not, you can pass it to other people. Where's the square root coming from? Why is it square root? That just appeared out of nowhere? It's just a Pythagorean theorem with the squared already moved over on this side to make a formula for length. Could I have made a length squared formula? I guess I could have, but this is much superior in its calculation. So, here's what I'm going to do. I'm going to use the points given. They said just for any point x, y. So this is everybody on the circle. This is a bit conceptually hard. It's a bit conceptually hard to go, what do you mean x, y? I mean, anybody. All of the people that are standing around on the circle waiting to jump in and grab the calf cookie. They all have this true. What the heck just happened there? There we go. Their distance is going to be the same. I can calculate it. Once I put the point in here, what's the point of the origin? 0, 0. Okay, so that's actually easier. In the middle of a hard conceptual thing we're doing here, the numbers maybe are easy. The length of OP is equal to square root x minus 0 squared plus y minus 0 squared. And if your brain is short-circuiting a little bit, let me just explain what this means. Wherever you stand on the circle, out in the parking lot, if you take your x and y's, they're going to work in this equation. That's all I'm saying. So LOP, the length of OP, is square root, look how nice this comes out, x squared plus y squared. Now the magic begins. If you've been asleep a little bit so far in today's lesson, or haven't copied much down, this is what you want, what I'm going to do right here. So I'll switch colors. I'll switch to spring green, because we're excited about the weather. What's another word or another symbol for the length of OP in a circle? It's just the radius. So let me write that. But the length of OP is the radius. Exclamation mark. Like chess, exclamation mark. You chess players know what I'm talking about? When there's a really good move in chess, we put an exclamation mark down. So I didn't mean like I'm yelling at you here. I mean like, whoa, that's the radius. Therefore, radius equals square root x squared plus y squared. Maybe you're underwhelmed. Maybe you're like, it's just the Pythagorean theorem. That's all it is. Again, it's still just the Pythagorean theorem, but now with radius in it. Now, in this particular case, we actually move the squared back over, the square root back over. And so I go, also, that means r squared equals x squared plus y squared. And that is the equation of a circle, 2 exclamation marks. Everybody on the circle, if they take their x and square it, and their y and square it, and add those two things together, they'll find they get the radius squared. And it's because of the Pythagorean theorem. Pythagoras is not surprised by all this. But if little Pythagoras was sitting in the class here, he'd be looking at this going, yeah, of course it is. The distance to everybody on the circle will be the same. So all of us will get the same radius. It's one of those weird concepts in math that's like sort of slippery. It's like, what's going on? And at some point it's like, well, yeah, because we're all on the circle. That means all our distances will be the same. Every one of us, no matter what xy I use, you'll get the same value. I want to say the lesson's over, but it's not. There's some details, but that's the big deal right now. I'm going to get a little more specific in the box, and I'll go back if you need me to. Hang on. Study people who want to pick up their study game. You're like, I don't need a study game in this chapter. It's too easy. I know. That's what I was trying to say yesterday. Let's pick our study game up now so we don't have to, when things get tough next year in chemistry and physics and math and all these things you're going to take, let's not, one, try to figure out chemistry and physics, as well as figure out how to study. Let's get studying figured out on easy stuff, and then when the tough stuff comes, you'll be ready. Trust me, friends. This is the wisest thing I've said so far. So, the equation of a circle with center 0, 0 and radius r is x squared. Didn't switch back to my highlighter. Or switch out of my highlighter. Is, how am I doing? There we go. X squared plus y squared equals r squared. It's just the Pythagorean theorem again in a different application. And all it says is if you're on the circle, your distance will be the same as everybody else who's on the circle. Okay? Do you have questions? Oh, we're doing much better copying today. Thank you, friends. No phones? Headphones? Very good. Much better. How do we use it? Sometimes so easily. Sometimes circle questions are the easiest ones ever. You might finish this homework, and some of the questions in the homework in like 2 seconds. It seems like cheating. It just seems too easy. It says, a circle centered at the origin. Ah, good. We are happy. Centered at the origin. Can we do circles not centered at the origin? Yes, and it's not that difficult. But we're not doing that today. We're doing circle centered at the origin. Has a radius of 5. Well, I don't have to read anymore. I'm ready to do equation. I don't even know if it asks that. I immediately know the equation. X squared plus y squared equals 5 squared. Done. Done the equation that quickly. So if that feels too easy in the homework, yes, that part is definitely very straightforward. You can also write it this way. And I make no comment on which one's better. I just say you can see it both ways. You can leave the 5 as 5 squared so everyone can see the radius, or you can call it 25. Be aware, if they give you x squared plus y squared equals 25, you're going to have to think a little bit about what the radius actually is, if they've squared the number on you. Question? This is a 5? Oh, I don't know why I wrote that. That's a good catch. Thank you. It's time for March break, is it? Is it ever? X squared plus y squared. Everybody's like, where did you get the power of 5 from? I don't know. Well, I think I was looking at the 5 while I was writing. I made a mistake. Well, I didn't really read the question. I just jumped in and said, hey, if I got this, that means I get this. Now I'm ready to answer the question. It says, determine the x-intercepts. Huh? I'm going to do a blue circle. I want to do a blue circle. No fill. Here we go. Circle. There we go. Let me just move it around so it's in the right spot here. Is it going to let me? Come on now. How did I do? Did I put it right in the middle? Can anyone tell me, using what I'll call the method, what the they want x-intercepts first. What are these two intercepts going to be? What's that? 5. And -5. Not exciting, I don't think. If you know that that's a circle centered at the origin, it's got radius 5, the intercepts are 5 and -5. And how about the y-intercepts? Well, the same deal. This is going to be 0, 5 and 0, -5. But just a little bonus, I want to say, how would we do that algebraically? To get x-intercepts, set y equal to 0. And so I get x squared plus 0 squared equals 25. And I'm going to make a mistake here, friends. Well, not a mistake, an omission. That might make you think math is broken. When I set y equal to 0, I get x squared equals 25. And up till now, we told you to undo squared, you do square root. And I get 5, but I don't get the other x-intercept. We've got to modify our method with squared. We told you a lie. I'm sorry, we did. We said, if you want to invert, or you do the opposite of x squared, you do square root. And it's not true. You got to do plus or minus square root. And so this is how I get the plus or minus 5. That might be news in this lesson. It's going to come back to haunt you, though. I'm going to mention it a bunch of times. From now on, undoing squared gives plus or minus 5. Okay, 2 questions. Why didn't this come up before? Well, we were always doing the Pythagorean theorem. We didn't care about the negative side length. We wanted the positive side length. Well, let's think about it numbers-wise. Tell me a number that you square to get 25. Everybody says 5. But there's another number that squares to give 25. And it's -5. And I'm not being tricky. I'm telling you how it is. This is the way. Plus or minus square root, this is the way. And you can do the same thing with y-intercepts. To get y-intercepts, set x equals 0. 0 squared plus y squared equals 25. So y squared equals 25. From here on in, when you move squared over, it doesn't become square root. It becomes plus or minus square root. If that upsets you, grow up. Yeah? This is the way with square roots, or with squares. And then it said, find the equation of the circle. Well, I already did that. Maybe I was being a little tricky. I knew that was coming. Mr. Todd, can I just draw the graph to get the intercepts? Yeah, I'm okay with that. That's no problem, but I'm just trying to get you ready for other algebra coming later. On an easy example, see, this is what grade 10 students sometimes miss. On the easy examples, if we do a little more work, then when tough examples come later, we're not phased. Yes?
Sorry for the interruption. If there's any grade 10 students on the top floor who would like to go to confession, please go to the Divine Mercy room now. Thank you.
You are welcome to go. The video will be there. Any questions there? Do you need more time? All right. A circle is defined by the equation x squared plus y squared equals 49. Determine the radius. What's the radius of this circle? I will wait just a minute for you to look at it because this is the mistake you're going to make. It's 7. How did you know it was 7? Yes, 49. This is r squared. So to get the radius, I go root 49, which is 7. Now you're confused. You're like, why didn't you do plus or minus there? You just told us you got to do plus or minus the rest of the way. Actually, technically, what we should do is go, yes, plus or minus. Plus or minus. And then we do a little thinking and go, do I want both numbers here? This will be the way the rest of the time of your life for squared. You immediately go, do I need the plus or minus? Is negative radius a thing? And negative radius isn't a thing. So I only want the positive number. And if you don't like that, you need to get over it. That's the way squaring is going to be the rest of the way. Is you have to think and go, do I care about the negative here? And we don't care. You can't have negative radius. You can only have positive radius. Radius is the distance from the center. 7, not negative 7. Oh, draw a sketch. Okay, I can do that. Just because I'm excited about how good I am with this circle thing. I'm jinxing myself. Let's see if I'm actually good with the circle thing. I'm going to make the circle red today. And here comes the circle. There we go. And I'll put a little 7 on there. Is it okay? If you think this is really easy, good. I think circles can be really easy. If you get what's going on here, life is pretty straightforward. How do we use this? There's going to be some more questions here. How do we use it? Because I'm on page 5 of my 10. Each example maybe gets a little bit more difficult, okay? Do you have questions on this one? Do you need more time? A circle has center 0, 0. Okay, yes, it's always 0, 0. And passes through the point 5, negative 12. Oh, that's not the radius this time. All right, a little picture to help you think this through. Because I need, like, if you just thought this was all going to be easy peasy, maybe it's time to just check this out a little bit. Here we go, like that. And then it's the circle. Circle. Green circle. I'm going to go with green circle. No fill. Here it goes. And I'll just move that around so no one yells at me for not getting right in the center. And it said it goes through the point 5, negative 12. Somewhere about there. And again, I didn't draw a perfect sketch, and I did that on purpose because I'm giving you permission in situations like this to go, I'll draw a little sketch to get the idea what's going on here. And it says state the equation of the circle. Okay, I know the equation of a circle. I know the equation. X squared plus y squared equals r squared. And you should wake up now, friends, if you've drifted off to sleep, because this will take just a little bit of thought. This is the beginning of the tougher part of this chapter where you have to go, how am I supposed to know what the radius is? I'll draw it on, and then we need some help from somebody. I'll draw the radius on. That's not a straight line. Straight line. There we go. Radius on my picture. How am I going to get the radius? If no one can tell me, I've got to rephrase the question to really help. But let's just wait. Just wait for a second. How do I find the radius of this circle? Destiny. Say it again. Just sub those values right into the equation. If you had a different answer, get ready. If somebody else had a different answer, get ready. She's right. Just sub it in. We know x equals 5, y equals negative 12 satisfies the equation. We know this is supposed to work. So I can go 5 squared plus negative 12 squared equals r squared. See? Formulas with 3 unknowns look really scary, and they are really scary. But if they give you 2 of the values, then it's just sub and solve. 5 squared, ooh, I didn't put the squared in there, did I? 5 squared is 25. 12 squared is 144. Add those together. 169 is r squared. Now how do I get r? Yeah, and technically speaking, I should write plus or minus, and then say r equals plus or minus 13, but then after a little bit of thought, I go, I don't need that. Am I going to take marks off if you don't do that? Not in these situations. No, I'm not going to. I'm getting ready for those tougher situations when the plus or minus really matters. So now I've got the radius is 13. Now I can write the equation of the circle. Therefore, x squared plus y squared equals 13 squared. And you could write it as x squared plus y squared equals 169 either way, and I'll put that there just so you're ready for that if one of the homework questions does that on you. X squared plus y squared equals 169. Now, back to, I saw a couple people not frowning, but hesitating when she said just sub it in. This works great. I love it. Do this. Great. What was the other option available? Yeah, the equation we learned yesterday to do the distance and just find that distance. The distance is the radius, so you could have went and did what you did yesterday, which is use 5, negative 12 as your second point. Use 0, 0 as your first point and find that as a distance, and it happens to be the radius. You'll get the same answer. It'll all work out. In fact, the math is almost exactly the same. What's that? That's exactly right. If we did the thing from yesterday, you'd get r equals square root x minus 0 squared. 5 minus 0 squared. And then negative 12 minus 0 squared. You'll get 5 and negative 12. You'll get yes, of course. Maybe of course it is exactly the same thing because yesterday's formula was the Pythagorean theorem as well. Okay? But a different way of thinking to get there. One is like, I'm going to find this distance. Destiny's way was, I'm going to make this equation work. But same mathematics. Yeah, different thinking. Other questions there? Do you see how this is starting to get different? This isn't just, here's the equation, sub into it. This is like, which equation do I use? How do I use it? That's where this chapter can get a little more difficult. All right. More time there? All right. Example 4. Oh, same question. Here, you try it. Because something goes wrong here, and you got to make a decision about what you're going to do. Okay? You try this. I'll do it in a minute. It's a virtually identical question, but because of the numbers I've chosen, this will be slightly different. I'll wait for you. You try it out. And at least get to the point where you see not the problem, but the situation that's going to happen here. Yeah, it comes out to a decimal. Now, I need to warn you, friends. Math people and decimals, we're not actually that close of friends. As soon as we do square root 61 and it comes out to a decimal, math people start to think, is there any way to get out of this where I don't have to use a decimal? And the answer is, yeah, I could just use square root 61. Somebody says, oh, what's the radius? It's the square root of 61. That bothers people. They want the decimal. The math people are like, It's good the way it is. I don't have to figure out how many decimal places I have to write down. I don't want to have to write, what is it, 7.82425, whatever it is. I don't have to write all that down. Square root of 61. It gets better. Equation of the circle. This situation especially, I don't need the decimal numbers because the r squared is 61.
Instruction, could all grade 10s on the bottom floor who would like to go to confession, please go to the Divine Mercy Room now.
Don't misunderstand, friends. I'm not saying decimals are bad. I'm just saying if we can avoid them, we can get rid of all the worrying about how many decimal places do I have to round off to, writing it all out, writing an approximate equals. This equation is perfect. Perfect. Just the way it is. Okay? So I just put that in your brain, that maybe the decimals isn't the end-all be-all. I'll add one more thing. What did it come out to? 7.8? Yeah? In your calculator, go 7.8 squared. If you put 7.8 in there and go 7.8 squared, I want to show you the problem with decimals. What does 7.8 squared come out to be? No, 7.8 squared. 60.84. Oh no. It's not the same anymore. By rounding off, I lost some accuracy. And maybe in certain situations, that's fine. If you're building these blue chairs or these desks in this classroom, see how crappy they are? I'm sure they weren't too worried about whether it was 60.84 or 61. But if you want to build iPhones, this is a pretty big difference. Rounding off can make a big difference, and we don't want to do that. So how do we avoid it? We just use square root of 61. Then we avoid getting decimals that we have to round off. Okay? That's the big picture. You can ignore most of that if you want. This is the important thing. Yeah? Is the point -6, -7 inside or outside of the circle x squared plus y squared equals 81? This is the type of problem we're moving towards. Not just, oh, just write down the equation. Like, I got to do some thinking. And there's several ways to do it. So take a second and just look at this situation and go, what steps would I follow? What's my plan here to figure out if -6, -7 is inside, outside, or on the circle? Substitute -6 and -7 in for x or y. Yes? Totally will work. Now, part 2 of the plan. What are the 3 possibilities of the number you're going to get when you go -6 squared plus 7 squared? What 3 things could happen here? Higher, lower, or the same. If it's higher, that means a bigger radius. If it's same radius. It's on the circle. If it's smaller, yeah? So it's sort of a left side, right side check. So that's the way I'm going to write it up for you, because I want to bring that back. Let's do left side, right side, using -6, -7. Okay? The right side says 81. Left side says x squared plus y squared. Here I go. -6 squared plus -7 squared equals 36 plus 49. I get 85. It's not on the circle. Let's agree that it's not on the circle. It didn't come out to 81. But is it outside or inside? Outside. It was bigger. It had a bigger radius. So I'll write that in a sense. -6, -7 is on a circle with a bigger radius. Therefore, -6, -7 is outside x squared plus y squared equals 81. All right, that was one of 4 plans I think I could think of. I wasn't sure what somebody was going to say. So let's generate some other ideas. Just so you feel free in your homework to go, I don't have to do it the way Mr. Todd said. There are other ways to get to the answer here. Does anyone have another possible way to use the formulas and the weapons we've been given to find out if this thing was inside or outside the circle? You do? Guess. Ooh, maybe. What do you mean by guess? Oh, just take a guess. Just go, I think it's outside. Yeah, okay. If you do guess and check, I'm okay with that. So let's say you guessed inside the circle. What calculation could you do with -6, -7 to check? What's that? You could do left side, right side. That is one option, which is what we just did there. What other formula is available to find out? Sub it into here, see what you get, which is a lot like I did. I'm trying to draw out one more thing.
Square root 81.
Square root, oh yes. He says, why not square root 81? Find the radius here. And the radius here is 9. Find the radius of this one, and you'd find it was greater than 9. That's good. Also, I want to mention the distance formula. Take this -6, -7, and find out how far is it from the origin, and use the distance formula from yesterday. I'm not saying that's better. I didn't bring it up to say my way's better. I think this is the best way that we've done on the screen here. I'm just saying, when you're in these situations, this type of math is not the type of math where you sit there and go, how does Mr. Todd do it? How did you say to do it? No, that's not how we do this. That was true with y equals mx plus b. There were specific ways to do that. Here, for the rest of the chapter, there might not be one choice. There might be several choices of how you can get to the answer. Okay? And that's okay. So if you didn't do it the way your friend does it, but you got the same conclusion, it's okay. How many more do I got to go? 9 and 10. Here it is, almost real world. I'm not saying people in the real world are doing calculations with stones and frogs. That's not what I'm saying. But they might be doing calculations with oil spills in the ocean and using very similar mathematics.
Top floor who are wanting to speak to confessions today, please come to the vendor's room at this time. Once again, all grade 11s on the top floor who would like to make a confession, please come to the vendor's room at this time. Thank you.
A stone is dropped into a pond and sends out a circular ripple. Have you ever done this? Dropped a stone in a pond and it's a circle wave that goes out from the center. Yeah? It's increasing by 6 centimeters a second. Find the equation of the circle 12 seconds after the stone is dropped. What's the first thing we should do? You see, there's going to be multiple steps here. What's the first thing we should find out? 12 times 6, she says. She already sees what she's going to do. So I'm just going to label that for you, and we'll do a little communication. I'm going to say, we want the radius after 12 seconds. And she says that's real easy. You take the 6 centimeters per second and you multiply it by 12 seconds and you get 72 as the radius. And I put the units on there not because this is a lesson on units, just because I wanted to mention that centimeters per second times seconds is centimeters. So the seconds cancel out because one's dividing and one's multiplying. All right, that's step 1. Step 2, and I drew a line. I like doing this. I like drawing a line down going, I know I have something else to do, and that reminds me so I don't forget. I don't just stop there and go, I'm done. It says find the equation of the circle. Equals, hang on, I'm going to get you to say it again. You think about what you said, because maybe it's my ears. I didn't hear a key number here. So give me a second to write something here. I'm going to say the stone was initially at 0, 0. Does that matter? Maybe that's obvious to us. We'll just make the stone, wherever the stone dropped, we'll put our graph paper over top of that spot and we'll make that 0, 0. That makes our equations work. Therefore, the equation is x squared plus y squared. She said all that, and she said 72, which is correct. What else? No, x squared plus y squared equals 72 squared. Easy to forget in the middle of all this. And here's what happens to your brain. I know exactly what happens to your brain. Your brain goes, yes, I understand it's x squared plus y squared equals r squared. I did that before. And then in the middle of this, you're going, oh, I got to calculate the radius. 6 times 12 is 72. Okay, stone. Oh, I got to make it communicate well. 0, 0. Okay, and then all of a sudden, the 72 squared slips away. Yes? So make sure when you're done, you sort of focus out and go, ooh, did I get it all right? And compare it with your equation, which you've studied carefully. And if you don't study carefully, it's easy to make little mistakes like that. You're like, well, yeah, I still got 68 out of 70. I'm like, I know, but we're going to tougher stuff. Let's get the 70 out of 70. Let's get those little things down pat so they don't mess us up later. All right. If the frog is sitting on a lily pad located at -8, -11, how long will it take before the frog feels the ripple? Are we doing these calculations on frogs? No. But this is very close to answering this question. If an oil tanker hits the reef and starts leaking oil into the ocean, which we've done a shocking amount of times to the ocean. I cannot believe us humans. We just, again and again, we just continue to do things like this. We could say, oh, the shore is at -8, -11. The oil spill happened at 0, 0. How long before the oil hits the shore? How long do we have to clear all the wildlife out or to put up a barrier or do something? Same mathematics, different numbers. All right, now we need somebody clever. If a frog is sitting on the lily pad at -8, -11, how long before the frog feels the ripple effect? Here's all I'm going to do for you before I ask somebody. This is going to take 2 stages. Stage 1, we're going to and then stage 2, we're going to something else. Anybody want a shot at stage 1? What do we need to know first? What's that? Calculate the equation for where this frog is on the lily pad. Yes? I like it. There are other ways to do it, by the way. And we're going to talk about those in a second. He says, let's go x squared plus y squared equals r squared. And he's going to sub in -8 squared plus -11 squared equals r squared. Hopefully this stuff's all easy for you. You can type this in your calculator. 64 plus 121. Incidentally, sometimes I go a little fast on some examples on purpose because I don't think this is the point of this example. So I don't want your brain to get distracted on the details. I want to get to the point of the example. So I don't know. Maybe that's what the videos are for. Sometimes you're like, geez, you went a little fast on that one. I better watch that part again. What do I get here? 185? And so I square root that to get the radius, which I would love to leave as square root 185, but I don't want to upset anybody. I would love to leave it as square root at 185. Maybe I'll do both. I'll leave it as square root at 185, plus I'll get the decimal. Menu, 1, square root, 185 equals, see, my calculator doesn't want to switch it. It's like, my calculator says square root 185. It's like, are you sure that you don't want to just leave that just the way it is? You might want it just as square root 185. No, you're upset. So 13.6 is the radius.
Prior direction, would any grade 11 who would still like to make their confession, please come to the Vibrance Room at this time. And when all grade 12s on the top floor would like to make their confession, please come to the Vibrance Room at this time. So once again, all grade 11 who like their confession, and any grade 12s on the top floor, please come to the Vibrance Room at this time.
Okay. Now what? It says how long before the ripple gets there? The frog is 13.6 centimeters away. What now, Destiny? Divide by 6. Yes? Because that's how fast it's going. It's going 6 centimeters a second. It's got to go 13.6 centimeters. So it's divide by 6. Now, if that bothers you, I have a formula for you that you can use in these situations. Speed equals distance over time. And the reason I write it just like that is because it's on every road sign you drive by today. So as you're on the bus going home, or as you're walking going home, or getting a ride going home, just take a look as you drive by, and every road sign has this formula on it. Because what does it say? What's the speed limit right outside St. John's? 50. Maybe it's 40. Is it 40? Okay. Let's say it's 50, but then what does it say underneath? 50 what? Kilometers per hour. See, it says it right on there. The speed is the distance divided by the time. That's why this one's so easy to remember. Even if you're not really a physics person, it's a fairly easy formula to remember. So in this question, we want the time. So to get the time, we've got to take the distance and divide by the speed. Now, if you're like, ooh, that's a little much for me on a Wednesday before March break, that's okay. She told you what to do. She said take 13.6 and divide by 6. And maybe it's just that easy. So 13.6 divided by 6 equals 2.2 7. Is it? 13.6 divided by 6, 2.26666. Okay, so approximately 2.27 seconds. Notice, I could have also done t equals square root 185 divided by 6 and just left it like that, and it would be perfect. I wouldn't have to round, but if I did it using that, divided by 6, I would have got 2.2669. So it would be pretty much the same. Okay? But if you want exact answers, moving forward, if you want to work at Apple someday, leave it like this. What did I do there? Square root of 185. Oh, I had an equal sign there. I was going to get it as a decimal. But I just mentioned that. You don't have to do that in this class. I just mentioned this is a perfect answer, whereas this is rounded. Oh, seconds. Any questions there? All right. I think one more to go. Is it? One more? More time here? Last one. A line segment has endpoints 8, 6, and negative 6, 8. Show that MN is a chord? What's a chord? A chord. A chord is a line connecting 2 points on a circle. Oh, I went to just draw a circle there, which I don't need to. I've got my fancy circle drawing thing here. Here's the picture of a chord. If I was going to put chord on the test, I'd definitely tell you it was coming, or I would just tell you on the test what a chord was. I don't expect you to memorize that at this point. That's what's called a chord. Has anyone seen that before? You did in grade 9. Oh, well, that's great news. But again, I'm not trying to say, okay, you saw in grade 9, I'll put it in the test. Again, I wouldn't be able to do it. I'd type out a question, check if this is a chord, and then in brackets I'd say, a chord is a line connecting any 2 points. You know, I'm not forcing you to memorize that. Okay, well, what are the steps here? What am I going to do? You could do distance formula on this, and make sure it comes out to the right radius. Totally works. Great option. What's another option? I like that option, he says. Well, let's do it that way then. Okay? So let's find the distance from M to the origin both times. So let O be the origin, 0, 0.
Last call for any staff members or students who would like to do confession. Please go to the Divine Mercy Room now.
So I'm going to find the distance from O to M. Same as we did last night. 8 minus 0 squared plus 6 minus 0 squared, square root 64 plus 36 equals square root 100 equals 10. Is M on the circle? What's the radius of the circle? Yeah. The radius of the circle is 10. I just found out this point's a distance 10. So wherever it is, it's on the circle. Then find distance ON, which will be now square root negative 6 minus 0 squared plus 8 minus 0 squared equals root 6 squared plus 8 squared equals root 36 plus 64 equals root 100 equals 10. Therefore, both points are on the circle. They both are the same radius away. But you could have done it with that left side, right side check we did earlier. You could have just subbed in 8, 6 into x squared plus y squared equals 100 and see if it works. So again, I'm trying to get ready for tomorrow's lesson to go, sometimes there are multiple ways to approach this, multiple ways to do the steps. Any questions about that last example?
Why is it 0?
Because I'm finding the distance from that point to the origin. And that origin is 0, 0. So when I did O to M, I was going 8 minus 0 and 6 minus 0. That was why we put all the circles at the center, was to make the math easier. Could we move the center over and put it somewhere else? Actually, pretty easily, we could. But we don't in this chapter in grade 10 just yet. It's not that hard to move it around. Other questions?